has not been here before? 1, 2, 3, maybe 4. Who here has not been here before but doesn't want to admit it? No, just kidding. Welcome. We're a pretty sane crew, so just to point out to you who's involved, my name's Garth, I'm one of the co-leads. Sharif is a co-lead and founder. Nancy in the back, hi Nancy, is also our co-lead and our one of our new co-leads for 2020. And then there is Paul with the interesting t-shirt at the back. Hi Paul. We have a number of other volunteers, including the guy who's also my guitar tech, who's giving me microphones randomly. Hey, I can actually almost hear myself. That's disgusting. Adam deals with some of our video and pizza. Scott, who's trying to set up NASA mission control. And because we're streaming, so if you're on the lam and you do not want to be recognized by face recognition software, do not stand up here. Dave at the back, Minister without portfolio. I'm going to forget someone, and I am going to kick myself all night. Rick, who's not here, who is does our public service announcements and is also one of the lead developers of OWASP. Help me, guys. Who am I forgetting? I'm not forgetting anyone. Anyways, so this evening we're going to go through a review of a survey we did for reviewing 2019. We're going to talk about our call for papers. We're going to talk about our goals for 2020. And Sharif is going to talk to us about software lines of code that changed the world. Awesome. So in 2019, we did a survey to see how we were doing. What should we do? What should we not do? What should we keep doing? And with all surveys, we got pretty good number of responses. We got almost 50 responses, and every one of those people who responded actually finished them. It's not like they could ditch a shopping cart. So, and it took each of them, on average, about 2 minutes to complete, so it couldn't have been that hard. So, we wanted to get a bit of a background on who our members were. So we asked the question, are you a builder, are you a breaker, are you a defender, are you a manager, and also more importantly, are you a recruiter? So the spread is reasonably even between builder, breaker, and defender. We do have some recruiters lurking somewhere. Next question was, what is your security experience? And I always love this one because what's a computer? Good response for that. Junior, intermediate, advanced, and bow before me mortal. And I'm wondering who that person is. Sorry? There's 2 people. What if they're schizophrenic? How satisfied or dissatisfied with the events of 2019? And so we got a pretty good distribution. We're hunting down the somewhat dissatisfied, but you'll hear from us later. Generally, we got a pretty good response for this. So we think we're doing the right thing, but we're also have an appropriate amount of humility that we know we haven't always got it right, and we know we can improve. So if you have brilliant ideas, we want to hear them. Our meetups are too hot, too cold, just right. So we seem to be in the Goldilocks zone there. What do you prefer? And this is like pretty much average across the board in terms of time length. From 15, 30, 50, or workshops. So we'd like to be doing more workshops because there's a lot of good learning in them. But there seems to be this 30 minutes seems to capture our attention just the right amount. But this sometimes depends on, in our call for papers or our call for presentations, what people have the ability to present or what they're comfortable presenting with. Topics. We want to learn the world, apparently. So if we serve it up, you're going to take it. I like the eating pizza one, so there was enough interest in that. So if there's anything else we've missed from the question, because sometimes surveys can be leading, if there's something in there then that we've missed, or something that's not in there that we've missed, please let us know. We have a question.
We can't really see the categories. Maybe if you could talk about them, the results.
Let me try your glasses. Let me increase. Can I do this? Nope.
Just tell us what they are.
Oh, you want to hear my voice? Damn you, Nancy. Okay, so the categories were, I sound like Richard Dawson, writing secure code. Code's always secure, right? We don't need to know about that. Break all the things. Looking for the anarchists in the crowd. Using security tools. Security of emerging markets, emerging technology. Designing with security in mind. Threat modeling, eating pizza, and DevSecOps. Anybody got the bingo card? Did we miss something in that list? The Internet of Shitty Things? No, that would be emerging technologies. Okay. How likely would you recommend OWASP Ottawa Chapter to a friend or colleague? And so we got a solid 66% in terms of promoters. There are passives of about 28%. I'm looking for Canadian voters out there. And the same 3 detractors. I think those were probably my kids filling out the survey. There were some reviews, some handwritten reviews, and some I wanted to call out specifically because I thought they were very instructive, like Garth needs better clothes. No, I prefer the meeting location to be outside of downtown to avoid traffic and parking issues. And that's one thing we're trying to continue with our Canada meetups at lunch. And so those will be continuing in 2020. We don't have anything in Orleans, but that's the best burb we've got right now in terms of getting a meetup out there. No, I'm not comparing burbs. New to Ottawa, went to my first event at Hacker Trivia, so that was our trivia event. Felt welcome immediately, looking forward to 2020. So that's one thing we're trying to do, is make this a warm and welcoming event, including pizza. And then again, continuing events in Canada, very appreciated. And that's it for the survey. I'm just going to drop this on you. Typically every year we have a non-meetup meetup where people, if they want to sit down and have some sort of alcohol-induced rant at us, this is the time to do it, for feedback, if you want to volunteer, that sort of thing. And we will be having it at the Clock Tower after this meetup. Any questions? I've killed them all. All right, so up next, Nancy is going to talk to us about our continuous call for speakers.
Bonjour. Okay, so I'll try to make it short and try to answer all of these questions. So we started a continuous call for speakers to make it as easy as possible for you to apply and speak at OWASP. We want as many of you to come and speak to these meetups and make it easy. So we ask for, you don't even have to have your presentation ready, but have an idea, making sure that it's appropriate, that that we can help you come up with a topic. It can be a project that you're doing at work. It can be something that you do in your lab, in a lab. But anything that can be interesting, we want to hear about it. And also be able to plan better a year where we can cover different topics, right? If it's always the same speakers, and if we're only picking the talks that are coming to us, and it's also always the same topic that's not interesting to you. So please participate. So what's the benefit? A bit what I said, making it easy for you, giving us the choice and be able to plan the year properly. And how does it work? Basically, because of that system, you have a file under OWASP Ottawa, and the leaders can go over your presentation or your proposition, your submission, and discuss between us and see what's the most appropriate, and even discuss with you. In there, there's even an option that you can select and say, I'd like feedback from somebody at OWASP and discuss the topic. So we're here to help, you're not alone. What should you talk about? The survey gives you a good idea of what people want to hear about, right? So secure coding, DevSecOps, what else? Emerging technology, security tools. What I'd like to add to that is that we talk a lot about security tools, and we talk about best practices, but I think what's really interesting that we've had before is war stories, a bit of what happened to you. So we know we have to shift left. We know we have to patch, but why are we doing it? And can I tell your story, Anna? Okay, so Anna was just telling me that she's a developer and that they had a client who had all these security requirements and they're not, familiar with all of them, and that she came to B-Sides and she's coming to OWASP. And I would love to see Anna before the end of the year come here and see and tell us, how they started, what they did, what worked, what didn't work, and what was the result. So that kind of talk would be very, very useful for us. Who should submit? If you're here, if you're interested, if you're trying new things, please submit. And that's the link. You'll probably see it on our Twitter account, anywhere on social media. It's really easy. You can use your social login like Google or Twitter, any one of them. You'll have your bio. And a lot of other conferences, if you enjoy speaking here and you want to submit elsewhere, a lot of conferences use Sessionize or something similar. So you can reuse that talk and submit somewhere else and make modification. And even if they're not using Sessionize, it's something very similar. So it puts you into the system. You can actually make your account public and open to other conferences if you want as well. So that's all I had. Did you have any questions? Nope. It's your turn. Thank you.
Thank you, Nancy. I want to also add that OWASP is going through a revamp of our website. So we haven't launched it yet, but it's most of the content's out there, and we have a brand new OWASP Ottawa Chapter page. So the Sessionize link is there. And Nancy has set us up with a LinkedIn company page. So if you're looking us up on LinkedIn, you can find us there as well, besides our Twitter account. So we're all over the social media. Yes? Sorry? My name. Yes, thank you. What is my name? My name is Paul. I'm also with Sharif and Gareth and Nancy, one of the leaders of the chapter. I think you introduced me at the beginning of the meeting, but my name is Paul again. And I also wanted to wish everyone a happy new year and tell you about our New Year's resolutions. Okay, so these are largely based on the feedback we received along the year, and also the survey that you saw. We have had a very successful workshop at the University of Ottawa, focusing on secure coding. We got a lot of good feedback, a lot of interest. We had about 140 people signed up to that event. About 80 showed up, I think, or 70. But good representation. A lot of students learning about secure coding, and the target that we want to bring more education. And if we can bring more secure coding education in universities to the developers that are learning and becoming future developers, we feel that we are reaching our goal. We also think more workshops here is a good idea. If there is something in particular you want to see, let us know. Talk to me later. As we mentioned, we're going to have more meetings in Canada. We had a break there because of construction, and it's always hard to find a host. Here, Shopify is graceful to host us. We saw the feedback that it's would be good to have meetings otherwise than downtown, but it's not always easy to find someone to host us. But Shopify and Trend Micro are our hosts, and we're going to continue that through the year. And that's pretty much all I had. I think we're going to give you a break, and then Sharif is going to talk next. Should we give them a break, like 5 minutes? Or we go straight into the...
I don't know, let's read the room.
Let's read the room.
Do they need a break?
Show of hands, do you need a break? Yes or no? Raise your hand if you need a break. Okay.
They're an intense crowd, so...
Okay, sounds good. So, over to Sharif.
Thank you.
You still need to set up with the presentation. It's a cable switch break. Oh, there it is. Let's plug that in. Okay, so while Sharif is setting up, although he needs no introduction, I sure know him. What is it, 7 years since you started the OWASP Ottawa chapter? 12. Okay, so Sharif Kusa, I'll let you introduce yourself as well. He will be talking to us about the lines of code that changed the world.
There we go. Nice.
Yeah.
All right. Can you guys hear me at the back? Oh, we're back. Oh. Yes, we have a problem.
Just to make sure it's not mine. Plug that in.
Is there a website that this Dosing Passport website might be
Let's see if that glitch says, well, stable, but we don't actually see anything. Is it, could it be the wire? Maybe it was working properly with, can you check the first draw, memory source, if there's a cable there? What cable is that? Oh yeah, there's one out there.
In case you were wondering, we're having an impromptu presentation of abstract art in the new media. Good karma, everyone. No? Bad karma. Bad karma.
Maybe, or the refresh. It should just be 1080.
Oh, yeah, see now it's working.
Yeah.
It's 60 hertz.
Who was at B-Sides this year or last year? So had you been to the OWASP room? Did you see the gazillion-dollar presentation system they had there? Which we had to keep getting them to turn on and turn off. Don't anybody move.
Okay, that's what we tried one last time.
That's why there's pizza.
The one that actually goes there? No. It works when it's not in presentation mode. Yeah. I have no idea.
Wait, what do you use? Oh, you use.
You haven't been in these? Okay, so I guess at 9 or 8 o'clock. And they still haven't fixed it?
Do you want to send me the presentation? We can put it on my box. Sure.
All right, so after all, we're going to have a break anyways. Let's take 5 minutes. And we'll get you, we'll switch laptops and then start from,
They said they didn't want to break, but they lied.
yes, yes.
Okay, it's state. B, try changing slides.
Try change. Just go next slide.
Go to that
Gently.
slide and go back again.
Hey.
Okay.
Okay,
Okay, no break.
so no break after all.
All right, how's everyone doing? Damn. Hello. How's everyone doing? Good. Good. How many are developers in the house? Nice, nice. Now, security folks. All right, managers. What the hell are the rest of you doing, guys? All right. Oh, recruiters. Okay. All right, so today I decided to switch things up a little bit. So the people who know me a little bit know I like to talk about source code, I like to talk about software a lot, right? So I'm going to talk about the lines of code that changed the world. So the way that I divided my presentation is we're just going to talk about software and how it really got everywhere. And I'm going to talk about the lines of code that changed the world from a good perspective, the lines of code that changed the world from a bad perspective, and what to do about it. And I'm going to bring examples from what Google and Facebook did about this problem. Not to say that Google and Facebook is the reference, but it's just an example of a good engineering practices. Cool?
Just try to stand in this area.
Yes, I can.
So you're like not right in front of the
Sure. So I'm a software developer by education, by training, spent about 9 years writing really buggy code. And since then, I'm trying to fix all the problems that I created. So started writing code professionally in 1999, joined OWASP 2006, wrote a bunch of open source code for WebGoat. One thing led to the other. I find myself writing a lot of questions for exams for GIAC, JSSP Java, JSSP Net, to be exact, about 500 questions. So if you took those exams and you cursed, that's going to be me. All right? One thing led to the other. I find myself working for Wells Fargo, 2009, doing security code reviews, so I looked at a lot of code. Started software security in 2010. That is one shitty logo. I apologize for that. Anyways. And recently, I launched another company called, what we do at Software Security is that we offer something called penetration testing as a service. So those companies that don't have a penetration testing team, we kind of become their penetration testing team. For Reshift, what we do is that we help software developers write secure code early on in the software development lifecycle. All right, so software is eating the world. Anybody know who uttered those words? That's a very famous quote by Marc Andreessen. Marc Andreessen is the guy who created Mosaic, the first web browser, and was the co-founder of Netscape, and recently became a really successful venture capitalist, put money in Google, Facebook, Uber, everything. So he knows a thing or two about software. But just to explain how software is really everywhere, I'm just bringing 3 examples. The largest taxi company does not own any vehicles. It's a software company. Think about that. The largest accommodation provider does not own any real estate. It's a software company. What? Oh, that one. And the largest, the most popular media owner does not create any content. It's a software company. So I created a career out of estimating software, about estimating the complexity of software, understanding the differences between different softwares, understanding the complexities, understanding how a particular software for a particular industry, the way its architecture, how does that translate into complexity. And I need to do that because I estimate applications on a daily basis. So that's my job. But I try to figure out a way so that you guys can appreciate how much software goes into a particular problem, right? So I did this basically. So just for you to appreciate the size of software. So for a pacemaker, there's about 80,000 lines of code for this little thing, right? For an F22 Raptor Jet, it's about 2 million lines of code. For a Chevrolet Volt, it's about 10 million lines of code to run this thing. For the Mars Curiosity Rover, it's about 25 million lines of code. For Boeing 787, it's about 32 million lines of code. I mean, that's not really a good example because about 30 million of those is pretty shitty. That's why the airplane was gone down, right? But you guys can just get the idea, right? All Google's code, everything, is about 2 billion lines of code. How do we know that? Because Google is famous of using single repo. So all of their code is actually in one single repo. I'm going to talk about that a little bit later. All right, so software has really changed our lives, right? And I'm just going to go over lines of code that has changed our lives positively. Space War. Anybody familiar with that? So Space War was the first game written on a computer. That computer is called PDP-1. It was the size of a car. Cost $120,000. In today's money, it's about $1 million, right? But the significance of this is that 5 months later, they used the same code base and created multiplayer version of the game. And basically, that set the stage for all of the gaming industry, which is a multi-billion-dollar industry. Everybody in this room played games at some point or the other. Don't tell me no. I know you do. Right? The next one that I want to go over is the Apollo 11 lunar module's bailout code. So Neil Armstrong, everybody knows who Neil Armstrong is, could not have landed without this piece of code. And what this piece of code is doing exactly what it says, bailout. So basically the, the Apollo guidance computer, AGC. AGC was basically this piece of software that was supposed to guide Apollo to the moon. And its computing power is equivalent to the machine that you record your messages with today. That's how they got to the moon, using the same computer power as the piece of software that writes your greeting message on a phone or a desktop phone or something like that, right? So obviously, it has a very limited capacity of dealing with space and memory and computations and whatnot. So they wrote this routine, and this routine, what it was supposed to do is basically figure out if it's running out of memory, it would deprioritize all of the non-essential data and non-essential processes and focus on the most essential processes. So 30,000 feet from the moon, an alarm code of 1202 rang. Neil Armstrong and the other guy who was with him didn't understand what that is, so they didn't care. It did that 3 times over. Later on, they figured out that this bailout code did what it was supposed to do. And the reason that this bailout code existed in the first place is that the folks who designed this figured out that we probably cannot test every single scenario that's going to happen in space. And just to make sure, let us design this so if something crazy happened, at least Neil Armstrong does not become space pizza, right? Which actually happened. So 30,000 feet before, because the computer was trying to figure out a lot of calculations in order how to, what's the trajectory, what's the angle, blah, 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 the conditions, etc. So it ran out of memory 4 times, and that code did what it's supposed to do. Without that code, probably Armstrong would not be able to brag and say his famous words, "The eagle has landed." Next is the HTML hyperlink. So Tim Berners-Lee is the one who came up with this, with the link. And basically the link is that thing that linked all of the World Wide Web together. He didn't come up with this. What he came up with is those 3 letters, : // And what did that do is basically it standardized the way that the web can talk to each other. So everybody can now agree on a standard way to link HTML pages. And obviously, this was a very, very important piece in the technological advancement of the web. Next is the JPEG. And JPEG stands for Joint Photography Expert Group. And basically, this piece of code right there is the compression that allowed for the JPEG to happen. So before that, sending an image was a very big deal because images was very big. So JPEG algorithm, what it did is that it uses a lossy compression algorithm to make images smaller. So basically, shades of color that the human eye cannot track, things like that. Tracking pixel, the day we sold our souls. So the one pixel image was used to basically adjust by web designers in the 90s to adjust pages layout. But then somebody figured out, well, this thing is used everywhere. So now I can know who and where is accessing a particular page, and then I can adjust and drop a cookie, and now I can adjust my content. So this is all to say that software is eating the world. However, the eating is not going very well. Because while software is eating the world, somebody is having an indigestion. So let's start with the code that is not really great. The Null-Terminated String. So in 1972, Dennis Ritchie made a fateful error while he was designing his language C, right? So there are 2 ways to represent a string, right? You can get a box and say, this box takes 10 characters, and only 10 characters. If you need 12 characters, you need to get a new box, right? Or you can say, well, here is a pointer to a bunch of strings. You know that the string is done when you see a null, right? And that's the mother of all bugs, because buffer overflow that we're still suffering from until this day is created basically because of this. Obviously, C was used and abused in a lot of languages, especially operating systems, because it's fast nature and running. And this didn't go away particularly. So this is one of the problems that we're still suffering from until this day. The next one is the Morse worm, 1988. And basically, this is the biggest evidence that we as a human race don't learn. And we're doomed forever. Because here's an example. 30 years ago, somebody told us how bad this can go. And basically, using this worm, he took down 10% of the 60,000 computers that were connected at this time. And we still didn't learn, right? So this is just a piece of the Morris worm. Everybody know what the Morris worm was? And how it works and all of that stuff? Garth, you know?
I was like that.
You wasn't? Yes, you were. The idea is that Robert Morris didn't really want this to be a worm. He was just trying something. Anyways, he was indicted under the Computer Fraud and Act something and was did probation for 2 years, but then he went in and created Y Combinator. So he ended up very well, so you don't have to worry about him. Next is the one-line virus. Anybody know what this line would do in old versions of Linux? What was that? Spawns a little shit on a process. That's correct. So somebody figured out that it's a cool idea to call a function colon. You know colon? This is a function name. Right? This is a function name. Most programming languages wouldn't allow that. But the guy who created Bash thought it was a good idea for some reason. So what this code does is that it's going to recreate itself over and over and over again. I guess it's some kind of recursion, right? Until it consumes all of the memory, and the computer would be gone. Machine, the operating system would be gone. And again, 2002, right? This is when this was new. Probably was added to the source code way before this. Remember the I Love You virus? Yes. In 2000? Yeah. That was the same idea, right? While this didn't affect anybody, the I Love You virus affected 10 million computers, right? Microsoft. Next is the ECAR virus. Anybody know what the ECAR virus is? Pen testers in the house? Test virus, benign test virus. And this line gave every pen tester a freebie in their pen testing reports, because what this guy does is that if you are a pen tester and you want to test whether the application is running an antivirus or not, you just send this. If it's running an antivirus, it will catch this. This doesn't do anything. It's just a way to test the antivirus. If it doesn't catch it, then obviously that application is not running antivirus. So if that application accepts any files, you can send it whatever shit you want. It's not going to catch anything, right? Sammy Worm. A guy, his name is Sammy Kamkar, created a cross-site scripting worm that affected 1 million accounts on MySpace. That was 2005, 15 years ago. Cross-site scripting, still here today, right? Next is Heartbleed, 2014. And basically, before that point, everybody trusted open source. Open source was this thing that is untouchable. It is great. It doesn't have any bugs. Doesn't have any security flaws. And then Heartbleed happened. And it told everybody how open source is just like any other software. Could have bugs. Could have security flaws. Right? Cloudbleed. Anybody remember Cloudbleed? Yeah, it didn't really matter that much. Didn't really change anything. But the idea behind Cloudbleed is Cloudflare, which protects millions and millions of websites. Their business depends on the fact that they read HTML, parse it, add some stuff into it to make it much faster, and serve it back again. And basically, the bug was using Cloudflare, you can run remote code execution, and you can read the memory of the server. And how this happened is they were using a parser, some kind of an old parser. And the problem, and they switched to a new parser called CF-HTML. And by the virtue of using the new parser, this opened up the bug that existed from the beginning, but wasn't really visible because the way both of those parsers were modules of Node.js. And because the way they were using it, it didn't really appear with the old parser. It did appear with the new parser. All right, got it. So what do we do about it? You guys heard about all of the advice: shift security left, culture change, focus on developers, and especially this piece, focus on developers. I'll let this guy talk about it. No, seriously. Seriously. So, no, we all heard about okay, shift security left, give the developers the tools they need, maybe train developers, et cetera, et cetera, et cetera. So I wanted to actually get an understanding of companies that implemented security on scale for software development code bases, right? So I looked at what Google is doing. And just to understand Google's environment. One, it's called, they use a trunk-based environment, okay? So it is, they have a master, and everybody uses trunk. There's no feature branches. The branches are only used for releases, etc. Build system using customized build version of something called Bazel. Analysis tool. The analysis tool that they have is not complicated, as in there is no inter-procedure analysis, there is no data flow analysis, none of this stuff. They use very, very simple static code analysis. And finally, testing, big focus on unit tests, integration tests that are maintained by developers. So one of the things that they tried to do in 2006 is implement traditional static code analysis at scale. So what they did is 2006, there's a tool called Bugs. Anybody heard about Find Bugs? It's a static code analysis tool, so they integrated at scale. And they integrated with the build system, so every night it would scan all of Google's code. And the first attempt didn't work out because basically they created a dashboard for developers to go and see what happens during the night, find the bugs, fix them, and hopefully a second time they go away. There was very little adoption among developers because it was outside the workflow of the developers, right? So the second thing they did is, you know what? We're going to find all the bugs. We're going to bring all of the Google developers for 1 week to fix all of those bugs. So they ran Find Bugs again, 2009. 9,473 were found, but they were only able to review 42% of those bugs. Half of those were filed as bugs, so the team thought that they are enough importance for them to file those bugs, right? And out of which only 650 were fixed, right? So only 16% were fixed. Again, that doesn't work because obviously there's a lot of bugs that initially they thought they are important, but comes time to fixing, they couldn't fix them. So they did one more thing. They integrated the tool into the code review process, right? So basically, Google is big on code review, so they integrated Find Bugs so that it can deliver the results into the code review. And two problems happened. One, false positives. And two, because it was part of the code review process, so there was different analysis. So the same bug could happen in two different code reviews. The first time, the first team would say, yes, this is a bug, and fix it. The second team would say, no, this is not a bug, and wouldn't fix them. So there was no consistency between the different, across the organization. So 2011, they canned Find Bugs. And Google takeaways from that is basically, if the tool is not integrated, it's not going to be used. If it is not actionable, it's not going to be used. If the findings are not actionable, it's not going to be used. Tools is not trustworthy because of the lots of the false positives. And finally, it's too expensive to fix. So a lot of the times they find the bug too expensive to fix, and it's not worth fixing after it goes to production, right? Something called survivorship bias. I'm going to talk about that in a little bit. So what did Google do? So they created their own static code analysis tool. Very, very simple tool that uses basically regex, right? So they didn't go fancy at all. And the reason they did that is to make it very easy for software developers to create rules that work for them, right? And they added the tool to run at compile time. Why compile time? So basically what happened is 74% of Google's employees deemed the results are worthy of fixing at compile time versus 21% at code review time for the same exact bugs. So 100 bugs, if you show them at compile time, 74% of the time they're going to be fixed. Show them at review time, 21% they're going to be fixed. Why?
When it shows up at compile time, it's more urgent. You are in the zone of working on that code versus at compile at review time. You must move down to something else, lose interest in that issue or that project.
But also with compile time, you're used to finding problems and fixing, because that's part of what you do.
That's part of what you do.
It's part of what you do to make this
Right
compile.
then and there.
Yeah, you go, oh, I'm going to compile it, oh,
Yeah.
I'll find a problem, I'll fix it, go on, move on. So it's just, you introduce, you just moved into the same process.
So the people who written this paper, their justification for this is something called survivorship bias. As in, if I found something late on the process, so my bias towards fixing it is much lower because you know what? A lot of people have looked at this. It's not really a big problem to fix. Sorry, it's a big problem to fix. It's a big effort on me to fix versus if it's early on, I have a bias to fixing it because one, I'm in it, I'm gonna fix it, and the problem is just go away. Versus if it's later on, then I'll probably have more bias towards letting it go. So measure on production. For example, if bugs appear on production, you are more likely, not likely to fix them unless there is a big impact. Because usually the justification is, well, we have been living with this for years. Nobody complained about it. So that's one form of survivorship bias. What about Facebook? So Facebook development environment is as follows. Again, trunk-based development using Mercurial. Branches are only for releases. I didn't know this, but Facebook is a PHP shop. Really? Yeah. However, they use something called hip hop, which compiles PHP into C so that the engine runs much faster. So they don't have so there's no build system, basically, right? Analysis tool, this is the one difference between Facebook and Google is that they use complicated analysis tool. I'll show you how. And testing, there's no QA, there's no testers. There is developers who write test code. The same as Microsoft, the same as Google, the same as all of those big guys. And this is how it works. So let me explain what those are. Infer is Facebook's static code analysis tool that tests only mobile code. Okay? And the goal for Infer is to find bugs and ship them to GetAFix. I'll tell you what GetAFix is in a little bit. And on the other end there is something called Sapines. And Sapines, what it does, it is basically a tool, again, created by Facebook. And all what it does click some buttons on the Facebook application, trying to find bugs, trying to find a crash, trying to find a 404, try to find a problem. So this guy finds statically bugs in mobile code. This guy tries to find dynamically bugs in all of the other desktop applications or web applications, right? This guy and this guy suggest fixes. So GetAFix, it has templates of bug fixes. So for example, I just found it's a null exception, right? So you have to test for null. So that's the template. So this is what GetAFix does. What SapFix does is a little bit different, and that's the reason that it's connected to Sapines. This guy, what it does is that Sapines find a problem. Sapines go and check when this problem introduced and try to find the commit that just happened before this problem. And SapFix takes that and try to understand what the problem is and either completely or partially reverse the commit. So if it was really bad code, it will just reverse the commit. If it was just bad code that needs a little bit modification, this is where it goes to get a fix, to get a template, modify the code, and suggest a bug fix to the developer, right? So Facebook went really fancy on this.
Is SAP fix something from SAP or just?
No, this is just a name. SAP fix, yeah.
Just a coincidence?
Yeah, just a coincidence, not SAP. No. Anyways, here are it's really fascinating what they're doing. So if you're more into this, you want to know more, these are the two links that explain what these tools are doing and how they're doing it. All right, so takeaways. Traditional security models don't work. What is working for a central auditing team, for the security team, does not necessarily work for the developers, right? That's one thing that we learned from those two examples. Developers need help. However, they are not going to come to you and say, we need help, right? They are going to come in and basically complain about how security team sucks, right? That's a cry for help. They just cannot verbalize the words saying we need help, because that's not something celebrated in our society, right? If they come and complain and whine, it's another cry for help, right? So I was talking to this CISO about a month ago about tools designed for software developers. And he was just like, why? I was like, because software developers are busy, because they are not security experts, blah, 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 blah. So he was not on that page at all, right? He was not on that page at all. So I said, okay, what are you guys are doing? He said, we set the policy, and the developers have to follow. I said, so in my head, I didn't say that, but in my head, I said, I'm going to look at your Glassdoor evaluation, and I'm going to see what developers are saying. And sure enough, it was 3.2 out of 5. There you go. Yeah. There you go. Right? So developers need help. So I know a company, I think, so the security person in that company, I shouldn't be saying the company, but I'm going to tell you the advice. And what they do is that they do scan the code. They do not go to the developers with a problem. They go to the developers with the fix of the problem. And this is how they build trust, because the developer job is not security. The developer's job is development, right? So unless the developer, you go to the developer with help, with I'm going to take something off your plate, you're going to get shunned, right? And finally, if it is not automated, it's not going to be used, right? While security people like the driver's seat, security people like manual cars. If security is a car, security people like manual. They like control. They like to be able to push the gear up or push the gear down. Developers like autonomous cars. Developers like, okay, this security thing, I care about it, but just put it in the 10 other things that I should be doing. So if you can help automate that, that would be great. I'll be on board. If you can't, then too bad. I don't have time for this. And that's all what I have tonight. You guys have any questions?
What do you recommend for medium-sized companies to do?
So one thing I learned from this is there's no one solution that fits all. So while Facebook went very, very crazy on the technology, Google went very, very regex, like really greps in the code. So it really depends on the culture of the company, how mature the software development team as far as security. So I've seen multiple models. So there's the model of, you know what, we need a shock. So get a really good pen testing team to show the developers how the code can really be broken. I've seen that work. I've seen another model where, hey, we just need our developers to understand. Is training gonna do that? And then developers are training they need a few more interest in security, and those guys can be champions to tell the rest of everybody and guide the way, right? And there's what Facebook and Google did, which is, we're going to make it that simple. We're going to make it very easy for everybody to consume application security tools. And we're just going to make it a no-brainer, right? So it's, yep.
When you say that the security experts come to the developers with a solution and not with with an issue, how does that help the developer not recreate the same mistake in the future?
So let's agree on one thing. Developers are smart, right? And the good developers take pride in what they do, right? So if you wrote code before, you kind of relate, right? Like two developers sit down for beers. They're gonna talk about how the code was nice, and they're gonna be joking about bad code, right? Okay, so let's agree on that. So basically, you come to a developer with a fix. One, they're gonna trust you, and that's the problem that we have today between developers and security people. There's no trust, because developers people think of security people as annoying, right? And security people think of developers as dumb. How can you do that? Who does that, right? So that's the problem. So there's no trust. So what that fix communicates is, hey, you can trust me. I understand what you're saying, right? I can speak your language, right? And now, once we have established this, there's no walls. The developer's not going to be defensive. Now he can, okay, tell me a little bit about this. Why did you create it that way? And then, cross-site scripting, for example, there's a whole lot of... So the developer can go and Google and understand, right? Because he doesn't want to look that way again.
But you don't think it's the security expert's job to educate the developer on how not
Absolutely.
to do this in the future?
Absolutely. But again, we're trying to break the trust gap. So I can sit in front of a bunch of developers and tell them how dumb they are and try to teach them, right? While they kind of agree, but they don't want to really listen to that and will try to get me off their back as soon as possible. Or I can try to help. And again, we just agree that developers need a lot of help. So it depends on the angle that you're coming with. Yeah.
Back to the Google stuff that you mentioned,
Fix it. Yeah, fix it wheat.
You mentioned that only 16% of issues were fixed in the end, right? It's before that.
Correct.
Yeah. So was it because they just ran out of time, or were the rest of the problems did not be problems at all?
So I think the paper didn't really mention, but they mentioned the survivorship thing, right? So I'm talking to developers all day long, right? And the developer, when they see an issue, right, there are three things they're thinking, or three tasks that they have to do. One, I have to understand the issue. Two, if it's an issue, I have to make a decision whether to fix this issue or not. Three, I actually have to fix the issue and write the code. What's the easiest way to get rid of the three tasks? Ignore. Right? Ignore. And then, poof, the three tasks is gone. On to the next, right? So there is no way you can fix 10,000 issues in 1 week. Or in this case, it is 4,000 issues in 1 week. Even if all the developers in Google are involved. There's just no way. That's a lot of code, because sometimes you don't understand what the code is doing. Sometimes it's too risky to change. And sometimes, should I fix this one or that one that seems a little bit more risky, right? Any other questions? Yep.
So you said that Google's solution was to put the code analysis in the compiler, right?
Correct.
Did it eventually get to like doing the same kind of thing at the linting level?
What is the linting level?
Like as you code, instead of having to compile the code to find
No. And the reason that the compilation worked is the way they did it, they had to work on the AST tree. The AST tree only is created once you compile, right?
So it wasn't possible.
it wasn't possible. Yeah. Any questions, folks? Yep.
I have a comment that's not really about security, but could be tied in. I noticed both Google and Facebook, they agree on one big issue. Avoidance of branches.
Yes.
Because I worked in a company 15 years ago, and the head of R&D was obsessed with branches. Everybody branch this, branch that.
Yeah.
Oh, you want to try something out? Just
Yeah.
pick a branch. So people were branching and merging all the time. I guess maybe they agree with me in that case, that branches are trouble and are a recipe for bugs or losing track of what's going on.
So I don't really know why they picked the one repo thing, but I know a thing or two about branches. Is that even if you're a small team, like 20 people, you're going to be creating probably tens of branches a day. Fast forward a year, and there's just thousands of branches flying around, and that will slow down the whole source control engine.
Oh, okay.
Right?
You just add garbage in the database.
Once you create the branch, nobody really cares about, you want to move on to the next level. So unless you have really diligent developers who delete every single branch after they're done with it, it becomes really a mess. Multiply by a few thousand developers at Facebook and Google, you can understand how big of a problem that is, right?
Security bugs, they just spread as well, because you
yeah.
branch and merge all the time.
Yeah.
People end up stepping over.
It might also be a cultural issue. Like 10 years ago, there was no branches. It was just, if you're using SVN or CVS, like it was master, and then there's the development branch, and everybody commits to the development branch, and once the development branch is solid enough, then we take that out to the release branch, and that life was good back then, right? So, all right. Thanks, folks.
There's 2 weeks of everybody their own universes. You have so many conflicts that takes days to bring them back together. That's why they brought them.
Thank you, Sharif. I'm now officially creeped out that you figure out I drive a car with a manual transmission. So, especially for people who are new here, when we first start up, we put up a laptop with public service announcements, and they sort of ratchet through, but sometimes we just don't talk about them because it's like some kind of secret. But I'm going to talk about them. So just so people know, so if you wondered, hey, what is that? Well, now you'll know. You can be a member of OWASP. And the nice thing about being a member of OWASP is that you actually, if you specify Ottawa is your chapter, we see that money. That helps pay for pizza. That helps pay for pizza. That helps pay for pizza. So, and drinks. Don't forget about drinks. Because we love our pizza. So here is a link that helps, that's where you can actually register and donate. You also get a free email address. Thank you to Shopify for hosting us and giving us a very cool place to have our meetups. So a lot of what we do would not happen without, having a roof over our heads and having sponsorships. So thank you to Shopify for that. I don't know this one. Do you know this one?
So SAM stands for Software Assurance Maturity Model. So that's a project basically for a company that doesn't have an application security program. They have different practices, and it's a questionnaire, I guess, and an assessment that you go through to tell you where you are and where you can go. So I haven't looked at it in a while, but there's a version 2, so you should take a look. And yeah, it's an OWASP project.
Thank you. Today I learned. Like we said before, and what Nancy said before, in terms of our continuous call for presentations, we like people to present in our communities, share what you've learned. And it can be lightning, 30 minutes, a full hour. So look to our link for our, here's our sessionized link. Or if you can't remember the link, then just find one of us. It's on our Twitter. We try to blast it out pretty regularly. Ask us on Slack. OWASP has a blog. They have an updated website. What? Blogs are so 1990s. New release of mod security. If you're into mod security, Apache, that sort of thing, there's a new version.
So they found a bug in version 3. So they basically, whoever worked on the core rule set, who does the configuration of the mod security WAF, found a bug in mod security v3. So they updated it. So they're blasting everywhere to update to 3.04. And they will publish on their website. They're leaving time for everybody to update, but to explain the bug before divulging the details of it.
Do they have a blog?
They do. A nicer one than.
Oh, she's saying it's a tough crowd. We're pretty antisocial, so here's all our social media links. We have a Slack, and there's a self-invite Heroku link here. We have a lot of channels. People ask a lot of questions. It's a community. Apparently, Web Security Testing Guide now has a Twitter handle. They're out of control. We have a meetup page, as you probably know. How many people, this is the rule, this is full transparency. If 80 people say they're going to come, we typically get 40 to 45. And it's been our pretty accurate bellwether. So if you can try to screw up our logic on this, please do, because then we get more people. But please, so the ask is, if you have an opportunity, if you say you're coming, come. Or if you can't make it, say you're not. It helps us decide how much pizza my kids get to eat as leftovers. We have a jobs channel on our Slack. So just to let you know that that's there. Google's season of docs. I'm guessing it has nothing to do with doctors, or it's not like a daytime TV show. So apparently OWASP Zap now has API docs, and they do have a pretty funky API. I've used it. Who here doesn't know what OWASP Zap is? You will not be electrocuted. So OWASP Zap is one of their flagship tools for web application penetration testing. If you've heard of Portswig or Burp, it's a competing product to that. It's an intercepting proxy, has a number of tools. It's free. That's in beer. And now they have API docs.
So they published a series about 10 videos explaining how the tools work. So you can download the tool and go on all-day DevOps, and the project leader of Zap actually goes through different functionality of it, and you can follow along.
Do they talk about incorporating it in a full DevOps cycle with Jenkins? Tune in and find out. And here is a list of all our volunteers and some of their handles. Who has used Juice Shop? So when you're learning and when you're practicing, it's great to have something that's very, very reasonable to test against. And Juice Shop is the current top OWASP project for having a purpose-built educational vulnerable environment. Fun fact, Kiminich is German. He chose the name Juice Shop because it's a translation to English of the German word for juice shop, which is slang for crappy shop. Don't go shop there. It's a crappy shop, so it's Slafzimmer or something like that. And so Juice Shop is the English translation of it. And that's it. So there, I'm done. Does anybody have any questions? Who won the FA Cup in 1967? Never mind. So I'm going to, once I get all my crap together, I'm going to try to find my way down to Clock Tower. Anybody who wants to join us and contribute and tell us what we're doing right, what we're doing wrong, do you want to volunteer, what should we be doing, or just chill, we're going to be down there. Thank you.